This short video is just a quick discussion about the packaging of integrated circuits. For a more detailed explanation and discussion, please visit the link in the description. Basically, there are three categories of players in the production process: the foundries, the fabless, and the OSATs, which stand for outsourced assembly and test companies. These three companies work with each other to produce the ICs that we use. The fabless designs the circuits which the foundries manufacture that is to be assembled and tested by the OSATs, then marketed by the fabless. There are also companies called IDMs which solely manufactures, designs, and packages their own ICs. In terms of packaging, the single die packaging has only a single die with a single function in each package. The SoC is like a complete system on its own. The MCM is composed of multiple interconnected chips with multiple functions. SIPs are like MCMs that are stacked, so therefore smaller in size. SOPs are like SoC and SIP, but its passive components are embedded in the substrate, which makes it more compact. Packaging technology can be classified into three. Traditional packaging has two methods: the pin-through hole, where pins are inserted through the hole and then soldered. An example of this is the Atmega 328P in the original Arduino Uno board. Another method is the surface mount technology, where the components are soldered only at the top of the board. An example of this is the Mega 328P, which can be seen in my generic Uno board that uses QFP. Another subtype is the PGA, where the pins are found on the surface of the chips. PGA can be seen in AMD's Ryzen CPUs. Since the pins are found on the surface of the chip, it is more fragile. Another type is the ball grid array, which uses solder balls rather than pins for easier soldering. In this type, the chip would be attached permanently. There is also a micro FCBGA, where the die is facing downwards. Before going to the 2.5D and the 3D technology, let's first talk about the silicon interposer. The interposer is a way of interconnecting IC components with the use of wires. They make use of the TSV technology, which we will discuss later. It has higher density interconnection and has an excellent thermal and electrical performance. It is used for low power applications. There are two types of interposers: the passive interposer, where the substrate only contains passive components, and the active interposer, which has active components in the substrate. TSV offer vertical pathways through the silicon interposer. There is a dielectric present between the TSV and silicon. RDL serves as horizontal pathways and UBM serves as mechanical connection. 2.5D and 3D packaging has a lot of common characteristics. They both make use of the TSV technology. They have low power consumption and much smaller than the traditional packaging. They also have faster performance, which makes them more expensive. The main differences are the kind of interposers used, heat management, and orientation of integration. There are three interconnection techniques: the wire bond, flip chip, and interposer. In flip chip, the chip is flipped, so the top side faces down. Interposers can have a TSV, TPV, TGV, RDL, or bridge. Under wire bond, there are three types: the ball bonding, wedge bonding, and the stud or bump bonding. During packaging process, there are two tests done: the in-process test and the post-process test, to ensure the quality of the chips and its components. WLP has a reduced package size and better performance than the traditional ones. They are cheaper since they are produced in batches and has higher yield. They are much cheaper and reliable than gold wire bonds. Photolithography is used to print the circuit to the dies in the wafer. WLP can be done in two ways: the fan-in, where the packaging is done before dicing, and the fan-out, where the dicing comes first and the good dies are selected and repositioned and then packaged. Fan-out WLP could be mold first or RDL first. Mold first could be face up or face down, where the mold is applied before the RDL. In RDL first, RDL is applied first before covering it with the mold. PLP is another approach on packaging that uses fan-out, and instead of being in a circular wafer, a large square panel is used where it gives more yield per surface area. But since it is still on evaluation level, it still lacks standardization since it is bigger and heavier. They are also prone to warpage of the mold and the dies could shift. Both wafer level packaging and panel level packaging has a higher yield and a cheaper price, but they still have issues that are yet to be solved in the near future.